Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see HVDC transmission system, high voltage direct current transmission system. We're going to see how it works, and we're going to see what are the different types of DC links. In previous video, I have just explained the electrical supply system. I would recommend you people to go and watch that video first and come back to this video so that you can understand the basics about transmission, right? High voltage transmission, right? So when it comes to HVDC transmission system, this is very important question in this particular unit, right? And normally we use HVAC transmission, that is high voltage AC current transmission system, because AC transmission is very easier when compared to DC, right? Whereas we have a lot of advantages and as well as disadvantages in HVDC system, right? So we will see first what is the need of HVDC system and what is the disadvantage of HVDC system, what is the challenge we have here, right? So the first thing is, when power is transmitted by DC, you have a lot of advantages where the amount of insulation required is very less in DC transmission. And similarly, the components required for DC transmission system is very less. The towers, the cross arms, right, all those things which is required for AC transmission, right, are required very minimum in DC transmission. And it improves the stability of the system. The power factor of DC transmission system is unity. There is no changing current, right? All those are advantages. But when it comes to advantages of HVDC system, when implementation of HVDC system, we cannot completely rely on these DC systems. That is because you have to need, there is a need of AC components. That is, we don't have equipments like transformers, right, where you can step up and step down the voltage according to the need in DC, whereas that is available in AC. That is the main drawback in HVDC system. So transformers like step up and step down transformer is not used. Another thing is, power cannot be generated at higher voltage because of computation problem and the limitations we have in switching devices and circuits, right? That is of great problems in HVDC system. So here what we use is only for transmission. Well, understand here, for all these drawbacks, right? So the system is designed in such a way that you have AC transmission and then AC will be converted into DC, right? And again DC will be converted to AC and it is sent to the consumers. This is the normal working of HVDC transmission system, right? And when it comes to HVDC transmission system, the very important point is, whenever the distance is very large, right? If it is very large, then we can go for HVDC system, right? Because if it is more than 600 kilometers, the implementation cost of HVDC will be very less. It will be less when compared to AC systems. Whereas if it is within, this is greater, if it is greater than 600 kilometers. If it is lesser than 600 kilometers, if it is within 600 kilometers, right, then the implementation of HVDC system is very costlier when compared to HVDCs, when compared to the AC transmission. So normally HVDC system will be preferred for transmission over for longer distance, over 600 kilometers, right? So as I said, this is the complete structure of HVDC system, where you will have the transmission part, where you can see here the generation part, and here it's a transmission part, and again the distribution part, right? Whereas here you will understand the AC generator, the power is generated using AC and it is stepped up, right, similar to the electrical supply system, right? So it will be stepped up, and here this is where it will be transmitted as HVDC, that is high voltage direct current transmission. Whereas here we have two converters. In HVDC we will have two converters. One is rectifier unit, another one is inverter unit. You know what is rectifier unit? Rectifier unit, here it is, the AC is generated, the rectifier unit converts this AC into DC, and this DC will be transmitted through this high voltage transmission line, and again this DC will be converted to AC, right, and that voltage will be stepped down and it will be sent to the consumers, right? And as I said before, overhead transmission lines where if it is above 600 kilometers, if it is above 600 kilometers, you can see DC will be lesser than AC. Whereas if it is within 600 kilometers, then AC is lesser than DC, right? So this is the complete working of HVDC system. And when we say HVDC system, you will understand different types of DC links. What are the different types of DC links? When we say different types of DC links, we have three different links. One is monopolar DC links, which is monopolar DC links. Another one is bipolar DC links. Another one is homopolar DC links. And these are named after the use of conductors, right? So we'll see one by one. In monopolar DC links, this is HVDC system. So the HVDC links where the transmission is similar, whatever we saw. Like you can see the generated AC power and then it is sent to rectifier. It will be converted to DC and again here DC to AC conversion. So the concept is same, but what is monopolar DC link? In monopolar DC link, you will have only single conductor, whereas you will have only single conductor and it can be of negative polarity or positive polarity, but most probably it will be used as negative polarity. It will be used as negative polarity. And you can see here these two poles, right? These two poles will be grounded, right? It will be earth using an electrode, right? So in this monopolar DC link, the return current will be taking this particular path. That is, earthing will be used as the return path, right? So, and also the distance between these two poles will be approximately from 15 to 55 kilometers, right? And sometimes this is, earth is used as return path and you can also use a metallic return path also can be used, right? And you have a lot of several disadvantages here because of this particular electrical ground return path, and this monopolar link is not commonly used nowadays, right? So why it is called as monopolar DC link is because we use only single conductor. Apart from it, the operation is same, right? And what is bipolar DC links? In bipolar DC links, you will understand here, it is called as bipolar DC links because we use two converters, right? That is, we will have two conductors. That we will use two conductors. You can see here, one conductor here and one conductor here, right? And as usual, you will have two converters. One is rectifier, another one is inverter. You know what rectifier will do? Rectifier will convert from AC to DC, and inverter, it will convert from DC to AC. The operation is same, the AC transmission and then DC transmission and again it's AC, right? But why it is called as bipolar DC links? You can see here we have used two conductors and two conductors, one conductor will be of positive polarity and the second one will be negative polarity, right? And these conductors, right, these conductors can be grounded, right, using the electrode. It can be earth at the middle, right? The midpoints of this particular converting stations will be earth through electrodes, right? So which means it also create a return path through this particular link, right? So what is the greatest advantage of bipolar link is because if one conductor fails, then other conductor will start working, will still supply power, because this particular earthing, right, this earthing of electrode, right, this will act as a return path, whereas this path alone will act as a monopolar DC link and it will serve. That is the greatest advantage of bipolar DC link. So if one conductor fails, the other conductor will still continuously provide supplies, right? That is called as bipolar DC link. And what is homopolar DC link? When it comes to DC link, the homopolar DC link, even here you will have two conductors, but here two conductors will be of same polarity, right? It can be of positive polarity or it can be negative polarity. And even here the center of this converters will be grounded, right? It will be earth, right? And it can be even a metallic return as well, right? But homopolar polarity is not commonly used now. And even though we can use both positive and negative polarity, most commonly negative polarity is preferred, right? And apart from it, the operation is same, where you can see it is AC transmission, and then here it is DC transmission, and again it is AC converted and transmitted, right? And rectifier will convert AC to DC, and inverter will convert from DC to AC, right? The only difference in these three links, that is the monopolar link, bipolar link, and as well as homopolar link, is the conductors which we use. If we use single conductor, then it is called as monopolar. If you use two conductors of different polarity, then it is called as bipolar DC link. When we use two conductors of same polarity, then that is called as homopolar DC links, right? So this is very important question in this particular unit. So today what we have seen is, we have seen the working of HVDC system and what are the different types of DC links. I believe this video will be very useful for you. Thank you, my dear students.